Hello everyone and welcome to Abaqus FEM. If you've ever wanted to simulate explosion, fluid structure interaction, water impact, large deformation, or manufacturing process in Abaqus, then this package is exactly what you've been looking for. Today, I'm excited to introduce our Abaqus CEL and Eulerian Analysis Master Package, one of the most comprehensive practical training package we've ever developed. This package includes 28 real-world engineering workshops that teach you how to use couple Eulerian, Lagrangian, and Eulerian formulation in Abaqus Explicit to solve problems that are impossible or extremely difficult to analyze using conventional finite element method. Traditional Lagrangian finite element analysis work very well for many structural problems. However, when material experience extreme deformation, when explosion occur, when fluid interact with a structure, or when objects penetrate soil or water, conventional meshes become severely distorted and the simulation may fail. This is where the couple-Eulerian Lagrangian method becomes an incredibly powerful solution. In the CL formulation, structures are typically modeled using the Lagrangian approach, while fluid, gases, explosive, soil, and other highly deformable material are modeled using the Eulerian approach. This combination allows you to simulate complex engineering phenomena with remarkable stability and accuracy. Throughout this package, you won't just learn the theory, you build complete engineering model from scratch. Each workshop takes you step by step through the entire simulation process, including geometry creation, material definition, codes for the material, section assignment, contact interaction, meshing strategic loading, boundary conditions, analysis setup solver configuration, post-processing, and engineering interpretation of the results. The package is organized into five major application areas. The first section focuses on blast and explosion engineering. You'll learn how to simulate underwater explosion near offshore pipelines, internal explosion inside reinforced concrete and ultra-high performance concrete buildings, explosion around composite structure, buried explosive charge, shockwave propagation through soil, and even large-scale blast scenarios affecting buildings like nuclear explosions. Uh, the second section is dedicated to fluid structure interaction and sloshing analysis. You'll simulate water sloshing inside a storage tank under earthquake loading, blast-induced sloshing, seismic response of composite tank, and other free surface flow problem using advanced Eulerian technique. The third section covers manufacturing simulation. You learn how to model cold spray deposition, explosive forming, orthogonal cutting, friction stir welding of both aluminum and polymer material, and water jetwelling process. This example demonstrates how the Eulerian formulation can successfully handle extreme material flow during manufacturing. Next, the package moves into soil interaction and penetration mechanism. You'll perform simulation of pile driving, projectile penetration into soil, crash worthiness application, and soil structure interaction under large deformation conditions. Finally, you'll study high-speed impact and fluid interaction, including bird strike simulations, water impact of three-dimensional bodies, the impact of an airflow ball on water, and classical collapsing water column benchmark problem. By completing these 28 workshops, you'll develop practical skills that can be applied directly to research projects and industrial engineering problems. You'll learn how to create stable Eulerian meshes, define multi-material Eulerian domains, assign Eulerian volume fractions, configure advanced contact interactions, select appropriate constitutive model, apply equation of state for explosive, simulate fluid structure interaction, and efficiency, interpret complex simulation result. This package also introduces many advanced material models, including concrete damage plasticity, Johnson-Helmquist model, Johnson-Cook damage and plasticity, composite material model, ultra-high performance concrete, soil constitutive behavior, water, air, and explosive material through the JWL equation of state. Whenever you're interested in civil engineering, mechanical engineering, aerospace, offshore structure, geotechnical engineering, defense applications, manufacturing, or academic research, the technicals taught in this package are highly relevant to today's engineering challenge. This course is designed for graduate student, PhD student, university professor, simulation engineer, CAE analyst, industrial professional, and anyone already who already has a basic understanding of Abaqus and want to be master in advanced modeling and simulation. At the end, we have the payment section. The price of this package is 145 euros. We accept PayPal, Visa card, MasterCard, and all the cryptocurrencies. To order, please contact us through this email. We will let you know everything about the payments, the download links, and the content of the package, and any questions if you have. And for now, thank you for your attention.